So let's get this started. Thank you very much for coming here, and I do apologize for this mess. We should have tested it, really. And today, what I want to talk about is potentially how things are changing in our work. Who here is using coding agents to develop part of their job? Yeah. So this is absolutely amazing. When a new technology gets introduced, usually it takes years and years and years for it to become mainstream. This is the first time I remember where, this thing it became useful last September. Everybody's doing it now. And I think that the shift that's happened is really amazing because it changes the nature of how we do work, and nobody knows how to do it well. Anybody who claims to know how to do it well, including me, is just kind of lying. And I'm not going to claim that I know how to do things here, but I did start trying to research for a book. As what I do is when things are interesting, I force myself to write a book about it. That's the best way to learn. And I spoke to lots and lots of companies that have had some success developing with agents. And partially, that's kind of what I'm going to talk to you about. I've started collecting this data and kind of visualizing it to figure out what these companies are getting out of it and what were the prerequisites, what were the common things they did that enabled them to kind of go to a certain part. So with some level of confidence, I can tell you that, for example, if you want to get consistent agentic work, you need to do these things as prerequisites and things like that. So I'm not going to go and read through all of this stuff because it's kind of too complicated, but I will give you access to all of this for later. So if you scan this QR code, you'll get access to what I've collected so far. And it's an evolving thing. Keep visiting it next month, a month after. You'll probably see data that's cleaner and better. But I do want to talk about some things that I think we are certain about and how they will affect what we work. Maybe inspire you to do less stupid work. I think one of the kind of key things that's happening now is throughput is increasing. We can do a lot more work in the same unit of time. But the problem with that is some percentage of our work was really, really stupid. And while we were coding by hand, the stupid part of work was manageable. Now when we do 10 times more throughput or 50 times more throughput, the stupid amount of work is overwhelming. And that's kind of one of the key things that I really want to reduce for myself. I don't like doing stupid work. And I think kind of you shouldn't be doing that. So kind of going back to the original premise, we need to figure out what's going to change in the next 5 to 10 years. And then predict where to play now. But that's a ridiculous question. Because nobody can say that. If people knew what's going to change in the next 5 to 10 years, everybody would be winning on the stock market and kind of we would all be rich. So Jeff Bezos famously, in an interview in 2007 for Harvard Business Review, talked about how everybody's asking him a question like what's going to change in the next 5 to 10 years, but that's a ridiculous question. A much, much better question to ask that apparently nobody asks Jeff is what's going to stay the same. And he said that if you can figure out the things that will stay the same because you know these things, then you can kind of optimize your strategy around those. And then he did another interview a year later. He did 2 more interviews. There was a talk at the AWS reInvent conference 2 years ago where he repeated this thing like nobody asked me this question. So, I mean, if he's been saying something that nobody asked him this question for the last 20 years and people don't ask him, that's because they're afraid. So, that's feedback for Jeff. But let's create a strategy called Nobody Asked Jeff strategy to figure out what parts of our work are going to be the same. And then we can kind of figure out the strategy around that. So the first part, I think, that kind of has a potential to stay the same is what Albert Einstein described as kind of the most complex, the most important aspect of figuring things out is actually describing the problem. And That's the more essential part. The solution is kind of merely a matter of skill. So who thinks this is still going to stay the same 5 years from now? Half of the room. Okay, that's very, very interesting. So I'd expect more. So I think the reason why we can count on this thing staying the same is because kind of agents and agentic work, by definition, are representing us. An agent is somebody who represents you. So they're doing stuff that we tell them to do. They're not running around just building shit because they want to build shit. So describing what they need to build and describing the kind of the problem of what we're trying to create is still going to be essential for the whole thing, where the skill of building, I don't know. I mean, 2 weeks ago, I was building this part of a pipeline for my website where people will click on some things, and I wanted to make sure that as they're clicking on things, if the connection drops, the website app is going to collect all the answers to what they've kind of selected, buffer them, try to resend, queue them, try to resend, and then I started dealing with what do I do when somebody closes the tab and we still have messages to send. And I gave Claude the kind of task of doing that, and Claude said, oh, there's this kind of ping beacon API in the DOM that's been there for the last 4 years. It's completely synchronous. You kind of just put a message there. The website deals with everything you wanted. I'm like, okay, so no queuing, no retry, no. Like, okay, man, let's do that. So the skill of building something like that is figuring out, okay, that already exists in the website. I know how to design a queuing retry system and things like that. Unnecessary. The problem we were solving is let's make sure the messages get from the web app to kind of the server. So describing the problem is still the key thing to do. Solutions might or might not change. And we're getting to the point where Claude can fairly often propose a decent solution, sometimes stuff that I have no idea about. In this case, much better than I thought about. So kind of there's a bunch of tools that are emerging that are helping us kind of work on the problem side of things more. And I think they're interesting to investigate. One of these is SpecKit. SpecKit is a tool developed by GitHub as part of Microsoft, encoding their development agentic process and helping you kind of refine your specs and focus on specs. This is where they've completely stolen and repurposed the whole stuff around spec-driven development, and now spec-driven development means something completely different, but there is an effort there to help and codify how to work on defining the problem first in a more meaningful way. The danger with stuff like that is it becomes waterfall again, which we don't want to do, definitely. But there's a bunch of kind of other tools that you can look up online. One is called the BMAD method. BMAD method is Build More Architect Dreams or something like that. It's kind of, again, a process of kind of a collection of agentic rules, agents that help you figure things out, work on kind of the problem side of things, where the agents are, as they claim, partners and experts kind of collaborating with you. Then Amazon created a tool called Kiro that's also very, very interesting to investigate. Kiro is a full IDE. BMAD and SpecKit work with almost any kind of agentic framework. Kiro is a full-blown IDE that takes you from prototype to production, apparently, from what they're talking about, focusing on, again, cleaning up the specs, defining acceptance criteria, and all of these other things. So these tools are relatively opinionated. They enforce a specific process on you. SpecKit enforces a process that Microsoft has. BMAD enforces a process that, I don't know, whoever developed BMAD has. Kiro does the Amazon process. And what you will probably learn quickly, unless you're Microsoft or Amazon, is that their process is overly complicated. And it's not exactly kind of what you need, but it could be a really good start. So there's some other things that are worth investigating there. Auto is a really interesting project. It's done by a guy called Sam Khattoum, who I know from the BDD days when BDD was starting up 20 years ago. And his approach is kind of mixing BDD and kind of agentic development. And then there are things like code speak, which is like you just write a concise spec, like convert an RFC 5322 to whatever, and it does everything. So these things are kind of quite promising. I don't think they're there yet to replace developers, and I don't think they're going to be there in 5 years' time. But the trend is, I think, where people spend more time really refining the problem definition and the spec and things like that, and we're letting agents do more and more work. So this ends up really being problematic because that's the most difficult part of the job. Fred Brooks said this 30 years ago, where kind of the hardest part is describing what we want, and we're just saying, oh, you just describe what you want in the agent's build. Well, that's, you know. So who of you thinks this is still going to be the same kind of 5 years from now? Okay, slightly more. Good. So we're ending up basically saying, oh, you know, the work we like doing, the building stuff, this is a developer conference, we're all here because we like building stuff at some point in our career. That's no longer that important. Now we're turning into requirements engineers. Well, I didn't really sign up for this to manage requirements. But hey, you know. And then there's another couple of tools that I think are going to help with this. One is kind of when we look at the problem that Fred Brooks was describing, and everybody remembers the first quote, but they don't remember the continuation, is that basically the reason why that's hardest is that people don't know what they want. And even if they know what they want, they cannot express it well enough. Even when they can express it well enough, they're expressing only a piece of the puzzle that's in their head. They're not expressing like everything we need to express. And one of the things that he writes about in the No Silver Bullet is the problem of people not really thinking through the details. Yes, I can go back to CodeSpeak and say, take this RFC and just implement it. But there's a lot of details that get lost there. So on top of kind of or collaborating with the other tools I've shown you, there's a bunch of tools like narrative-driven is tied in with auto. And that's why I said kind of I like the direction where this is going, because it's taking the given when then BDD style of things and really making it more systematic to work with agents. Kiro, SpecKit, they will all pretend to do given when then. The given when thens they create now are laughable. Like no sane person with any experience would do that. All of these tools, they prefer the source of truth being in the code. Most of the time in tests, like JUnit tests, NUnit tests, Jest, or whatever. So the source of truth for these things is code. And code is really difficult to read for business people. So unless you are a single-person team and a single-person company where you are the business person and the developer and a tester, we need to expose that information somehow. So kind of this narrative-driven approach is an idea of how to do BDD in a more modern way with agents, and I like that quite a lot. And then there are things like CodePlane, where it's a really interesting approach of creating a DSL for describing the requirements. When I looked at this, it really reminded me of the work Tom Gill was doing 30 years ago on his kind of language. That was a special language for planning. But the technology wasn't there to take it really to implementation. And people are doing it manually. CodePlane is creating a domain-specific language for describing a system in detail, in specifics, so that they can check if things are consistent and then build it. So it's another very, very, very interesting approach. And kind of the issue with all of this stuff, again, going back to things that will stay the same, I think Donald Gauss and Jerry Weinberg wrote this book called Exploring Requirements that was published in 1989, one of the best books about managing requirements and tests and things like that. And in the book, they said that generally developers never work with requirements directly because requirements are the real world. Developers work with what they said was a map of requirements that is an abstraction of the real world. And that map can be simple, complex, colorful, black and white, with kind of simple lines, interactive, whatever, but it's a map. It's not the real world. And they said that one of the most important jobs for somebody building these systems was to actually explore the map and figure out what is there, what's there. If we know this part, what else is over there? And they were basically trying to explain how requirements are never complete, how we need to get to requirements through exploration. And part of what they were doing was using what's called the black box test to explore requirements that later turned into TDD, BDD, and all of these other things. Again, 1989. So, kind of, there are things like Allium. Allium is intended to be like a language for iteratively refining the intent together with an implementation. You kind of give it something, it explores the system and says, have you thought about this? It explores the system and says, have you thought about that? You kind of explore together until it gets defined. And I think, again, that's a very, very interesting approach. And amazingly, like, all of these things have emerged in the last 6 months to a year. So the ground is shifting quite a lot, but it's shifting in ways we can kind of predict. So Anthony Ulrich in 2005 wrote a wonderful book called What Customers Want, where he takes on a similar approach to what Weinberg and Gauss said. Basically says customers don't know what they want. I think that's going to stay like that for the next million years. And that's the constraint we need to deal with. And part of what Ulrich is talking about is how even when people tell you what they want, the literal voice of the customer, doing exactly what the customers want, is wrong because it's not their job to design a solution. Those people have a problem. They want the problem solved. They are not, in many cases, they're not software developers. There's only few, I guess, a small portion of this audience actually delivering to software developers. So your customers are not software design experts. Your customers are not scaling experts. Your customers are not database experts. We can't expect them to provide the system. And yet, the whole fake agile thing, the way most people ended up is just like literally following what the customers told them to do. So let's not do that. We've known about this being a problem for a long time. So we need to figure out how do we, as we are refining and exploring these requirements, also put in the stuff we know. Say that, this is not going to scale and you need to scale. Or we need to give agents better instructions. So one of the things that kind of starts going in that direction is the Spark framework. Again, Spark is something used on top of everything else. Spark is short for specs, pseudocode, architecture, refinement, and closure, which is kind of the process of, okay, let's start with the specs, but that's not where we are ending. We need to review what this is going to look like in pseudocode so that we can provide feedback from a development perspective and kind of architecture and things like that. So again, it's an approach that evolves. And there's a couple of attempts of bringing TDD and BDD systematically into kind of agentic work. One kind of I think has potential and worth investigating further is this AAID, or what kind of, which is kind of, the process description hurts my head when I read it. It's really complicated, but it is trying to kind of take the lessons that we had last 20 years and actually not ignore them as we're building things. Now, the problem with that is we're assuming that the development constraints are in the same places they were before. And we're optimizing for the constraints of 20 years ago. I don't know if they will stay the same. That's kind of one of those things that might change. So Weinberg and Gauss, in their book, talked about how basically it's much, 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 much faster to write black box tests than to write the system. And most organizations end up learning about whether the requirements are right or wrong by implementing the system and then realizing that they need to change. So this is where you deliver to the customer says, why is this like this? I wanted it like that. You change, you deliver. And they said, well, it's about an order of magnitude to write tests. And if you do tests, you can do exploration tests like what if this, what if that, because tests are concrete enough to complain. Now, the whole kind of taking BDD, TDD, and things like that into the development process is optimizing for this, because it's faster to get feedback on tests than to get feedback on the system, because the system takes too long to build. I think this part is no longer going to be the same. or already is not all the same. So I don't think it takes significantly faster to implement the system than it does to write the tests. So we have this kind of proxy that we were using to get feedback that's not as 100% of what we can get feedback on, and we were using it because it was faster. Test-driven development was giving us feedback on the system design, BDD, and things that were giving us feedback on requirements. Maybe, maybe not. I'm not saying, I'm just doubting this. But the other part that's interesting is the tests are still good for exploring the system. That's still true. And the question is, can we get feedback in some other ways? So one of the things I started doing quite often now is, when there's a new piece of requirements, I ask it to build a demo page. Like, show me exactly how this is going to look and work. Static, not connected to the backend, but functional. Like, use mock data. And then I can play with the system. I can get users to play with the system. I can get feedback, and I can say, what did you think about this? So the whole thing without a backend, done in like 2 minutes. 5 options done in 10 minutes. I can compare, and I can get people not to evaluate textual tests in given when-then conditions. I can actually just pump it in. I can show them these scenarios in real life. And then out of that, we can take the feedback and we can build the system, we can get the specs. So I think the important part here is that you can also complain much faster than explain, which is really, really interesting. So I use this trick with Claude very often now. When I'm thinking about a solution, I just tell it, like, give me 3 different ways of implementing this and compare it. It's set-based design. We've known from Lean for the last 30 years that set-based design is good. It was too expensive to do for most companies. By the time you've implemented 3 different designs to compare them, like, the time to deliver is passed. No longer. Like, I can get lots of different options, I can compare them, and this is really empowering. And I think that part of the job is really, really going to be interesting for people. But some other things are going to change in ways we can't really control that much. So I think, in conclusion, for this brief tooling review, what I think is really important is that feedback compression is really transformative here. What's happened in the last year or so is that the speed with which we can get feedback on designs, on experiments, on how this is going to work, on requirements, on tests, has increased significantly. And it gives us superpowers to do more stuff. Like, give me 5 designs, I'll compare, I'll make a decision. It's easier for me to complain than to explain what a good design is. Users can look at this, we can refine specs, we can do lots of stuff. Now, feedback compression has already happened multiple times in our industry. I think the first really important time when it happened was when interactive computers were introduced. And when people moved away from batch processing, where you need to wait a whole day to get the results, to something where you could type stuff and it shows on the screen. Then there was a bunch of other times when it happened, and the effects are similar. So we can assume that the effects are going to be similar this time. I think one of the most recent big shifts in feedback compression that happened in 1979. So it wasn't that recent. And in 1979, this thing came out. I'm the same vintage. I'm 1979, so I'm wasn't using this when it came out. So this is VisiCalc. VisiCalc was an invention of Dan Bricklin. It's precursor to Excel and Google Sheets and everything else. And it's the first time somebody actually put something where accountants could get immediate feedback, or people doing finance could get immediate feedback on the screen. And there was an interview with Dan Bricklin a few years ago in the Quartz magazine, and he was talking about what happened when this thing came out. And he said he remembers talking to people that said, well, when we had this thing, all of a sudden people doing weeks of work could finish it like in a couple of hours. And he remembers talking to some guy who said, like, everybody in the company thought I was a wizard. I was just using this tool, and I could spend the rest of the day reading books and drinking coffee and things like that. And I think that's the area of AI where we are now. I can code what I needed to code in 2 weeks in 1 hour, and then, I don't know, read Hacker News or watch Netflix or something like that. But then what started happening is companies understood this, the market understood this, and there was just a lot more pressure to work. So people filling the time with work. And I think that's what's going to happen next to us, where we will have a lot more pressure to deliver a lot more, because the market will understand that this thing happened. And your companies are going to understand that by using an AI tool, you can be expected to deliver 10 times more, and they'll pump you with 10 times more work. And this is where we have this problem of, the stupid part of work. The stupid part of work was manageable at my speed. The stupid type of work in AI speed is not manageable for a single human. And I want to challenge you today to think about what part of the work is stupid and to take it away. So partially kind of what started happening with Excel and things like that is people started using it for things that it was never intended to be used. And this is what we're seeing now with agentic tools being used for lots of different things, and people being overconfident, generating PowerPoint presentations that contain stupid data. My sister works for a healthcare research company and had to review a PowerPoint done by one of her directors where the PowerPoint was completely factually incorrect. And the solution that the AI agent proposed was illegal. Yeah, she kind of quit the job, not wanting to get arrested 5 years from now. So I think there's a couple of examples of this that I think are worth considering. One is during COVID, the British government used Excel to track infected patients. And at some point, there were more than 64,000 infected patients in England. Unfortunately, the version of Excel they used only allowed 64,000 rows. So at some point, the infection in England officially stabilized. And this is just ridiculous. It's completely ridiculous. I assume when Dan Bricklin invented Excel, he never thought that somebody will use, when he invented kind of VisiCalc, he never thought that somebody would use a tool to track like global epidemic in a big country. But hey, we got there. And there was an investigation after this, of course. There was a parliamentary investigation. They got some university professors to explain why Excel only has 64,000 rows and how Excel is not necessarily the best tool to use for tracking infected patients. And the university professor that kind of wrote up a report, I love the report, is Professor John Crowcroft. He said Excel was meant for people to just kind of muck around. You do a quick prototype, like, nobody uses it seriously. And he's like, you wouldn't use Excel, nobody would use Excel for anything seriously. This person is obviously an academic and never worked at a bank. This kind of banks run on Excel. And how they still run is amazing. And there are whole websites dedicated to kind of problems Excel's caused. One thing that I quite liked with kind of JP Morgan that ended up with in Financial Times is somebody did divided the sum instead of creating an average and got like data wrong on a big spreadsheet to kind of improperly reflect $400 million loss on a regulatory spreadsheet that caused a lot of issues for everybody. Nice, yes. So we are getting into this point where Excel is being used in ways nobody predicted, with overconfidence creating problems. And I think that's going to happen with AI agents as well. Similar stuff like this with similar losses. So Larry Tesler, the guy who invented copy-paste, a UX designer, basically created the law of conservation of complexity. It's modeled after Newton's laws, and Larry said basically you cannot kill complexity. There's an amount of complexity that's constant. You can only kind of move complexity around. You can make the front end more complex, making the back end simpler. You can make the back end more complex, making the front end simpler. The complexity has to go somewhere. And pretending that it doesn't is kind of pointless. So where kind of, paraphrasing this is you can't make complexity go away, you can shift it around, but what happens when you shift complexity around is we risk overconfidence. That's really the big issue with agentic tools now. We risk overconfidence. And there's lots and lots of examples of this. Again, one of the best examples of this that's kind of worth looking at outside of our industry is a year ago or something like that, there was a case in the US where the judge couldn't find any of the legal references that the lawyer submitted. There was an open and shut case where a guy got hurt on an airplane by a stewardess pushing the trolley a bit too kind of excitedly and hitting the person's leg, like really open and shut case. Everybody saw what happened. The guy sued the airline company. Because the US has precedent-based law, the lawyer had to submit previous judgments that were reflecting something like this, and they submitted stuff. The judge, doing his job, tried to check for these judgments, realized that he couldn't find them in any of the journals that the court possesses, and then asked the lawyer again to say, well, what journals are these from? Where were they published? And the lawyer came up with a list of journals that did not exist. And then the judge said, where are you getting these journals from? And he said, well, ChatGPT. So the case got thrown out of court, the lawyer got fined, and set an example for everybody. But in a brilliant act of kind of the legal system, the way it's supposed to work, the judge wrote up a conclusion that is amazing to look at. And in the conclusion, the judge said, this is not like prohibiting people from using AI. This judgment is not about disallowing lawyers from using AI. And he said, there's nothing wrong in using AI for assistance, but that's an agent. The agent represents you. It's your responsibility to make sure that the agent representing you is representing you in a good way. And kind of, he said that lawyers have, if they're using AI, they have this kind of gatekeeping responsibility to ensure accuracy. And that's fine. That's exactly what we need to do. This is what we need to do to prevent overconfidence. We have a gatekeeping role to ensure accuracy, and it's on us. So kind of, the problem here is the most recent Stack Overflow review that was published like a month ago says that 66% of developers don't trust AI. So more developers actively distrust it than they trust it. So this kind of accuracy thing is going to be haunting us for a long time. And I don't think any of the tools I showed you solves that. And I don't think any of the tools that I've used in the current generation of tools solves that or will solve that in any time soon. So we need to deal with that. That's kind of, apart from doing the specs, that's our part of the job. And I think this is going to stay the same for the next 5 to 10 years. So we need to kind of figure out what to do about that and how to work with that. So Ben Evans wrote this wonderful article about using AI where he said, people think AIs are expert colleagues, and they're not. They're interns. They are junior developers, they're interns. But unlike kind of previous situations where you have 1 or 2 junior developers on a team, now you have infinite interns. And I think that's a really good metaphor because there's nothing worse than I can imagine myself doing than managing like 500 interns at the same time. And all of the people claiming that they're running swarms of agents where agents are talking to agents who are talking to agents who are managing agents who are developing, who are testing, those are all junior developers. They might have read lots of books. They know the DOM API better than you. But you've basically given 500 junior developers a job of managing themselves. Like, that's going to end up really interestingly. So we need to kind of figure out, we need to check. And I think that's part of the job that nobody likes doing. I don't like writing tests. I don't like reading tests. I don't know any developers who like checking stuff. And that's kind of part of the stupid work that we need to reduce, but it's critical to remain there. And I have a couple of ideas how this can work in a slightly better way. So one of the first things to realize now is that The bottleneck is no longer coding, the bottleneck's shifted, and the bottleneck's human review. So you can ship as much code as you can review, reasonably. Stuff you can't review reasonably, I mean, it's okay for you to decide to ship it, but I'm not entirely sure if it's going to end up nicely. So depending on your risk level, if you're building something that's kind of internal for you that you can evaluate and you don't care if it works, just don't read the code. If you're doing a core banking system, probably somebody needs to read it. And kind of we need to optimize the review part of the cycle. So we need to optimize the diff. And what I mean by that is if you start reading everything that an agent can generate, you're never going to finish it. And we can't read, that's like an impossible suggestion. I can tell you, you need to read everything, nobody's going to do that. That's pointless. So we need to optimize what we read, how much we read, and where we focus. And one kind of way of doing that is to figure out how do we look at this thing from multiple perspectives, how do we reduce the amount of time we need to review. So all of these tools are basically going to hit you with the wall of text. And the more they hit you with the wall of text, the more nobody's going to read it. And people will start ignoring it. And what I think is useful is to kind of start with kind of any of these frameworks like BMAD or SpecKit or Kiro or something like that, and very, very quickly modify the stuff for your needs. So it doesn't generate the documents you don't read. It generates only the stuff you read. My current process, don't copy this, it's my process, I'm just giving you an example. My current process is I have this kind of intent tool that takes a one-liner of intent and turns it into a commander's intent document from Gary Klein's book that has like goals, anti-goals, out of scope, expected state, and things like that. And then there's another command that does impact analysis on the system to check what parts of code need to change. There's another command that needs to create an iterative plan with review checkpoints, and it kind of grows like that. So everybody and their dog is publishing their process as something that's the best. It's not. There's so many of these best ideas. They can't all possibly be best, but modify them for your needs. One of the kind of things that really ends up being tricky here is the time to feedback. Slow unit tests, serialized unit tests that execute like in sequence, slow integration tests. Everything that's slowing down feedback was manageable when a developer was waiting for CI. If you have kind of an AI waiting for CI to finish, that's pointless. So invest in speeding up feedback as much as you can, and kind of pretty much all the stuff that we were talking about that are good for humans, they're good for agents as well. It's just that ironically companies were not investing in them when humans were doing the work, but now they want to invest because agents can do stuff faster. So use that as an excuse. The other kind of part that's really interesting is we need to figure out how to test for unknowns. And lots of developers are now learning what quick check is and what mutation testing is and how machines can do exploratory testing on their own. So if you've not looked at any of these tools yet, now is the time to start investigating that. Build them into your pipelines so we can kind of figure out some part of testing for unexpected that machines can do for us as well. We don't have to do that. And lastly, I think really important aspect of what we need to review is figure out how do we get junior developers to provide evidence of what's done. So that we don't have to read the code, test reports, summaries, stuff like that that really provide CI test reports that provide evidence that something's been done in a good way so we don't have to read the whole thing. To start finishing things off, when we work with agents, there's really three things I think that are worth thinking about as what's provided to agents. There's the direction. That's kind of the spec. I want you to do these things. I want to build this type of tool. I want to do this kind of change. Then there are guidelines. Guidelines are how this thing is supposed to be built. Your architecture, your coding practices, your kind of other stuff. And then there are guardrails. Guardrails are the kind of concrete edges of the motorway where we're letting kind of cars switch lanes and speed up and things like that. That's okay, they're all going in the same direction, but there's a concrete bar there preventing somebody from going the opposite direction because that causes a massive mistake. So, and I think from that perspective, we need to figure out what are the guidelines and what are the guardrails in our process. And it's been a really, really kind of interesting philosophical journey for me. It's going to be a philosophical journey for all of you as well. But what I would strongly recommend as like a number one thing you can do to speed up your work is to automate the guardrails. Don't make guardrails markdown documents that say you're not allowed to do this. For example, we have this very specific domain class that talks to the network, and all the communication going outside of the application is supposed to use that class so that we have retries, auditing, security logging, things like that there. No matter how many ways I've tried to instruct Claude never to do a network request outside of that class, occasionally does it. And I need to read code. I've tried rules, I've tried hooks, I've tried the Claude MD, I've tried contributing MD. Occasionally does something like that. And these kind of things accumulate. And what I thought was, well, you know, if I knew how to write a custom ESLint rule, I could prevent it from doing this. So I started reading ESLint documentation to write a custom ESLint rule. And then I realized, well, why would I read ESLint documentation? I have a junior developer who knows how to read ESLint documentation. And I said, Claude, go and write me a rule that prevents this. And put it into ESLint, and write me a unit test for this rule so I can check that it's actually kind of catching the stuff it needs to check. And once it's there, it's automated. It doesn't spend tokens. It doesn't spend kind of any of the agentic stuff, but it provides a hard guardrail that sends it back. Plus, I can run it in CI. Plus, if I ever decide to stop using Claude and use something else, this thing still works. So, and from that perspective, I started doing more and more of this stuff, like wherever there is a deterministic thing I wanted to stop doing, I get Claude to automate itself. But automate with the deterministic thing. And when you're doing that, the really, really important aspect of this is, that's kind of slightly different when working with humans, but I think, again, good for humans, is the error message you provide. Can't just say this is not allowed. That's kind of good for humans that know what they're doing. If you do that with an agent is going to try to circumvent it 5 ways around. But if you tell it what to do, like you're not allowed to do this, use this class instead, we speed up the feedback quite a lot. So I think these kind of self-correcting error messages are really, really, really critical part of meta automation. So kind of, I think making the whole human knowledge that we have explicit is absolutely necessary to reduce reviews and diffs and things like that. Some of them you can do with guidelines, some of them you can do with guardrails, but pretty much aim for taking everything that you would have to teach a junior developer about the system. Everything that would be onboarding that takes months and months and months with a human developer, put it into version control so the agents can access it. And one of the key things that I think are important for this is that if you have, and everybody has that, more than one coding pattern in your code base, because something was done like this 3 years ago, then we changed how we do things, something was done a year ago, then we changed how we do things. An agent is religious, agentic coders are going to religiously follow a pattern you have, but they might not follow the pattern you want them to follow. That increases kind of your review, it increases your time. So I think as a very good aspect of kind of onboarding stuff, figure out inconsistent patterns and clean them up. You can get an agent to do that. That's an aspect of this. So kind of to finish things off, I think really what I'd like you to imagine is instead of onboarding new developers once every few months, imagine you have to onboard a new developer every hour. And what would you have to change in your process to do that? You would probably have to have a fully automated container with all the development tools set up. You would probably have to have all the authentication behind a single authentication key with SSO. You would probably have to have all the documentation easily accessible and kind of all of this stuff. And Lean tells us that if something hurts, we should do it more frequently to kind of identify the bottlenecks and fix them. And I think having to launch agents frequently and onboard them to our code base is exactly that. And by doing that, you will not just fix stuff for agents, you will fix stuff for yourself. All of this is going to help you bring new humans on board, even if we stop using agents 5 years from now. Thank you very much for your time. I hope I've tickled your imagination at least a bit.